Hi everyone. So I know that you have a monthly company. So
Yeah,
today
we're so sad.
today we're going to talk about something that will be very easy for you to understand. Okay, that are more interesting. So the first kind of sorting algorithm that we will talk about is called counting sort. Counting sort is a non-comparison based sorting algorithm that works well when there's limited range of input values. It is particularly efficient when the range of input values is small compared to the number of elements to be sorted. The basic idea behind counting sort is to count the frequency of each distinct element in the input array and use that information to place the elements in their correct sorted positions. So now we'll use this sequence to illustrate the process of counting sort. So now we have a unsorted sequence here. So first we'll find the largest element in the sequence. So after traversing the whole sequence, we'll find that the largest element is 5. And then we'll create an array from 0 to this largest element. So it will be 0, 1, 2, 3, 4, 5. Here are the indexes of the array. Then we will count the number of times and a number that will appear in the unsorted sequence. So we will find that 2 appears here first, so it will be 1, and then 5, then 3, then 0, and 2 again, so it will be 2 here, and then it's 3, 0, and 3. Okay, now we'll just write out the correct sequence with corresponding orders. So the smallest element that appears in the unsorted array is 0, and it appears twice. It will be 0, 0. So 1 doesn't appear in this array, so there's no place for it. And then we have 2, 2. Then we have 3, 3, 3, and no 4, and 1, 5. So now we have this array, and it is already sorted. And here we'll talk about the time complexity of this counting sort. So actually it will be O n plus m. So the n is the size of this input array. So we can take this example. So it's here 1, 2, 3, 4, 5, 6, 7, 8. So n is 8, and m will be the count array respectively. So actually m will be the size. M will be the size of this 6. So actually it is the largest element, the value of the largest element plus 1. So why is this complexity? Because first we have to traverse this whole array, so it's O n, and then you have to, when you print out the correct order of this sequence, you have to go through, traverse the array that counts the appearances, and that will be O n, so it is O n plus n. And here we talk about some advantages and disadvantages of using this kind of sorting algorithm. So the advantage is that counting sort generally performs faster than all comparison-based sorting algorithms, such as merge sort and quick sort that we have talked about last time. And if the range of input is of the order of the number of the input, so it will be very fast. And the second advantage is that it's very easy to code because you just have to declare one array and just increment every index of it when there's an appearance of an element. So actually there's no difficult operations that you need to do when you do the coding stuff. But it also has a lot of disadvantages. For example, counting sort doesn't work on decimal values because the index of an array cannot be a decimal fraction, and counting sort is inefficient if the range of values to be sorted is very large. We'll give an example. For example, we still have this sequence, unsorted sequence. However, the last value is 103 instead of 3. So in this way, if you use counting sort to deal with this sequence, you have to declare an array with 104 elements. Yes, and a lot of space is wasted. And counting sort is not an in-place sorting algorithm, so it uses extra space for sorting the array elements. And after talking about counting sort, we will talk about radix sort. So radix sort is a linear sorting algorithm that sorts elements by processing them digit by digit. It is an efficient sorting algorithm for integers or strings with fixed size keys. The key idea behind radix sort is to exploit the concept of place value. It assumes that sorting numbers digit by digit will eventually result in a fully sorted list. Radix sort can be performed using different variations such as least significant digit LSD radix sort or most significant digit radix sort. So yes, we'll use this sequence to present an example. So here is an unsorted sequence. And first, we will sort it according to the lowest index of this array. Will be so just we'll only compare this decimal place. Okay, so you can find that 0 is the smallest, so 90 will be put at the first place, and it will be this. In this order, and then you will sort it according to the next phase. And here you'll find that 0 is the smallest again. Okay, when we sort it with the second place will be 2, then it will be 4, and then it's 6, and then 7, and then 9. And then we'll find that this is 8 and others only have 0. So when we put that in the last place, it will be this, 45, 66, 75, 90, 102. So we still have 179. So it will be 9 for this place here, and this 7 here, here, and then this 1, so it's greater than 0 but more than 8. Yes. So this is how radix works. You just from right to left and sort with the number at this place, and then keep repeating this process. Okay, now we'll talk about the time complexity of this sorting algorithm. So it's O(n) times d. So n is the number of elements in the input array, and d is the number of digits in the largest number. So in this case, n will be 2, 3, 4, 5, 6, 7, 8, and d would be 3. So in the best case or worst case, radix sort performs similarly to the average case, as it processes all digits of all elements. And that's all for today's activity. Thank you.